What is going on, my e-learning human geographers? It's Mr. Majewski, and we are talking today about our first big unit of the year. This is the population migration unit. Now, we've already covered Unit 1, the basics, and then we moved to Chapter 9, development. But this is our first full unit, Chapters 2 and 3, population and migration, and it is a big one. We'll be on this for the next 4 weeks. So, we need to get right into the nuts and bolts of population geography. So a population geographer measures, well, obviously, as you might imagine, population, demographics, right? How many people are there? Where are they distributed? Why? How has this changed over time? Well, the answer is there's a lot here, and this is a really exciting topic to be involved in. Let's get to everything that we need to know, the basics of population. Okay, so the world's population is about 7 billion people, and it's growing by almost 70 million people a year. All right, so we will eventually get to 8 billion, we will get to 9 billion, and we may even reach 10 billion at some point. However, at that point, the belief is that our population will level off, stabilize, and it is pretty unrealistic to think that we're going to get above 10 billion people at any given point. But right now we're at 7, and we're growing at a crazy rate. 70 million people are added into this world every single year. So we have 70 more lives than deaths every year based on our current numbers. Almost all of the growth that's happening right now is in developing countries, LDCs. Of course, there are reasons for that we will be getting into, and maybe you probably already know some of them from development. But the point there is that almost all of the growth that we're going to see is oftentimes in countries that are maybe least able to handle that growth. So it's a worldwide problem that we all have to confront. Otherwise, the gap between developed and developing is really probably going to get worse. And a lot of the lessons that we, the United States and other developed countries, have learned as we've grown, we can pass those lessons along to the developing world so that they may not suffer as much as we have in the past related to these issues. So, 7 billion people. Our growth from 6 to 7 billion took only 14 years. That was the shortest time frame ever. So we are growing at a faster rate than ever before. Although, again, the good news is it's expected to stabilize at some point, probably close to the end of your lifetime. Now, here's the thing with population. 7 billion people, but we're not evenly distributed. We're spread all over. We're clustered in some places. We are not located in others around the world. So clearly there are reasons for that. Generally, as we already know, a lot of people live in flat areas. Most people live in flat areas, either plains or river valleys. We know why. It's easier to survive in those areas because it's oftentimes easier to grow crops. Lots of water. People tend to live in areas that have a lot of water for obvious reasons. You need it to survive, right? And you need it for agriculture. And often near the coast. Coastlines provide ocean resources, and they give people access to trade that they otherwise wouldn't have. So most people live in flat places, they live near lots of water, and they oftentimes live along the coastlines is where we notice the greatest concentrations. Now, population over time. Look at this chart right here. This is human population from 7,000 BC, 6, 5, 4, 3, 2, 1... even all the way up to 1 AD when Jesus was born. Look at this. Population never really gets above a few 100,000 people worldwide. And then look at this. We get to 1,000, right? We start to get to 12, 13, 1,400, and then boom. And look at population growth ever since then. Look at how it has skyrocketed, right? Over the last, few hundred years of human existence. But remember, humans have been on the planet for somewhere between 2 and 5 million years. But only the last couple of hundred have we really started to grow in any meaningful way. We call this curve that depicts human growth throughout history as a J-curve, and it's a J-curve because of the shape that the curve makes, right? You see how it forms that letter J there, and that's where it gets its name. So again, history is the shape of the J-curve really shows a lot of growth over the last few hundred years. Prior to that, it was really a flat line. So some pretty massive things have happened here to explain that. Now, The development of agriculture is one of them. When we have agriculture, we develop surpluses of food, more than we need. We can save it. We can store it for tough times in the future. Industrialization means, hey, we have new machines that provide for more food through agriculture, more industrial goods, and more importantly, more health and sanitation thanks to industrialization that's going to cause people to live longer than ever before. New technologies as well make life easier, mean that we can have fewer children, right? We don't have to have as many kids in order to do work for a family. In addition to that, new technology in regards to contraceptives reduces the number of children that each woman is having. So the J-curve is historically how population has been depicted. In modern times, the growth is starting to slow, and it will eventually stabilize. And it's going to create more of this. It's called an S-curve. Can you see why it's called an S-curve, right? Because of the S shape there. So it starts as a J, but as time goes on, this line starts to stabilize, and eventually it's going to flatline where we're not growing anymore, and maybe even start to come down again. All right? This is occurring already in developed countries. We're already seeing the S-curve in developing countries. It's the developed world where the growth is still J, where the growth is still exponential, which means it doesn't appear like it's stopping anytime soon. However, worldwide growth is expected to end by about 2100. So this J-curve is going to eventually turn into that S-curve worldwide, and we expect that to take place around 2100. All right? Take a look at this image as well. There's a lot going on here. First off, look at the world's population in billions. All right? So if we come over here and look at the numbers, just since 1950, the world's population has grown from about 2.5 billion to almost 7. So hey, in the last like 60, 70 years, right, we've seen a huge percentage of the total population growth in all of human history. So modern technology and innovations have led to a massive increase in the number of people. This red line shows you how much the population is increasing in terms of millions of people every year, and we have to come over here to see the increase. So again, as I mentioned earlier, we're gaining by close to 70, 80 million people on this planet every single year. All right? Now here's the good news. The rate at which we are growing, the percentage increase, actually is one of the lowest levels it's ever been. All right? So we're only now growing by a relatively small percentage every year. The problem is, when we're talking about 7 billion people, even a tiny 1% rate of growth still equals 70 million new breathing adults, or I should say humans, on this planet. All right? So before we get into the reasons why, let's take a look at some key terms that help us to understand human settlement. First, a new word for you. I doubt you've ever heard it before. It's called ecumene. It's a word we use to describe places where people live permanently. If somebody lives there, it's ecumene. All right? If nobody lives there, very simply, it's non-ecumene. Now, the amount of ecumene on Earth has gone up throughout human history because, well, we've had more people, and so people have spread out into new areas. All right? But the number of non-ecumenical places has gone down. It has gone down. However, we're also increasing the number of places that we can live on. In the past, you might not have had water in an area, so people couldn't live there permanently. Now we can bring irrigation or other innovations to it. So the amount on land that is ecumene has increased, while at the same time, the percentage of land around the world that is permanently settled has increased at the same time. Now, if a place is a non-ecumene, non-ecumenical, there's a reason for that. It's one of 4 reasons. One, this is pretty simple, all right? It's too dry, it's too arid, right? Dry lands, we call those. Those are usually deserts or semi-arid deserts. There's just not enough water to support agriculture, and so therefore people choose not to settle in those harsh, dry lands. Too high, highlands as they're known, these are areas that are usually mountainous or steep. They don't support agriculture, either because of the height, right, and how cold and harsh the weather is, or maybe you're on slopes, and so it's impossible to grow certain crops there. Too cold are polar areas. Again, it's simply too cold throughout a majority of the year to grow crops. In fact, in many of the polar areas, you have permanent ice called permafrost that's on the ground, and so growing crops is almost impossible. And the last reason is when we have wetlands, too wet of an area, right? There are actually some places that have too much water. We're talking about swamplands, for instance. So much water that there might not be enough dry land to settle on. or more importantly, there may not be enough dry land to actually grow crops on because there's too much water getting in there. So those are your 4 types of non-ecumene. Just remember the definition of what ecumene and non-ecumene is. The last thing I need on test day is one of my kids saying to me, ecumene, ecumene, what the heck you mean? All right, that's a little geographic humor for you. So where are people distributed? All right, well, what we know is populations are clustered in certain regions of the world. Now, are there people living elsewhere? Yes, but huge clusters, huge percentages of the world's population of people around the world happen to be clustered in certain regions. And the first region is East Asia. Eastern Asia has about 25% of the world's population, and China in particular. And so again, China has about 1.5 billion people. Remember, we only have about 7.5. So right there, China's making up a huge percentage. And East Asia as a whole not only has China, it has Japan, it has South Korea, it has the Philippines. All of these are very, very population-heavy places. And so it's the most populous, the most dense place in the world in terms of people being clustered together. The second most dense area, these are in order on this slide, is South Asia, and specifically India. India has about 1.4 billion. So between China and India, again, we've got close to 3 billion of the 7 billion plus people in the world in just 2 countries. All right, now South Asia also has some pretty populous countries besides India. It has Bangladesh, one of the most populous in the world. Pakistan is oftentimes put into South Asia as well. So again, right there, East Asia and South Asia, almost 50% of the world's population lives there alone. All right, we have 2 other major clusters. The third is Southeast Asia. So we have East Asia, we have South Asia, now in between we have Southeast Asia. These are the areas that include islands in Southeast Asia. That might be Indonesia. Indonesia is the most populous country in Southeast Asia. On top of that, we have some pretty populated countries in Vietnam, for instance, as well. And sometimes the Philippines is thrown into Southeast Asia, and they are a very populous place as well. So all 3 of the biggest population clusters in the world are in Asia: East, Southeast, and South Asia. And again, together, they make up over 50% of the world's population. Then, our 4th major cluster is Europe, specifically Western Europe. Now, this area is much smaller, a lot of smaller space. But again, we have hundreds of million people that are clustered in Western Europe as well. And so that makes up our 4th major population cluster. Now, hey, those are the big 4, East, South, Southeast, and Europe. But we have 2 others that you need to know. One, West Africa. West Africa is the fastest growing cluster in the world. So even though it's not in the top 4 now, it's going to get there soon, thanks to just massive growth that's happening in many of those developing countries in West Africa, especially Nigeria, which is the country that is going to experience a huge chunk of the growth there. And then finally, you need to be familiar with the Eastern North America. That includes not only the northeastern United States, but also Canada. And that's our biggest cluster. When I say our, I mean the United States. A biggest percentage of the United States population is located on the East Coast and specifically in the Northeast. And so when you combine that with southeastern Canada, where most of Canada is clustered, that creates a very important cluster, not in the top 4, all right, but still worth noting. Now, where are the most populous countries in the world located? Well, Mr. M has a little population chart for you. Okay, that's not available. All right, let's go to the population list. All right, there we go. And this gives you a list of countries and dependencies by population. And we already mentioned this. Look at China and India. 1.4 billion, 1.3 billion. You might be surprised to find out, the United States is the 3rd most populous country in the world. Behind those big 2, it's just they have like 5 times as many people. Each of those countries does as we do. But we're third, all right? So we're a pretty big country as well. Indonesia, I told you, Southeast Asia, that's the biggest country there. Brazil is your 5th largest country in terms of population. Pakistan, South Asia. Nigeria, I mentioned, West Africa, the fastest growing population cluster. Bangladesh, South Asia, right? So right there, look at this, India, right? Pakistan, Bangladesh, all considered part of South Asia for population purposes. And then Russia and Mexico make out the final 10. You'll notice Japan is up there. You'll notice the Philippines is up there as well. Those top 12 countries have at least 100 million people. Every other country in the world does not, all right? And as you go down the list, you realize, wow, look at the percentage of the world's population. Between China and India, about 35, 36%, right? United States, about 4%, all right? And then as you go down, obviously, you get into the 1%ers and even lower. All right? Look at Australia, for instance, just 25 million. All right, some pretty big countries here you probably know of or are familiar with, but those populations do not indicate maybe how big or small they actually are. So again, South Asia, very well represented. So is East Asia, with China and Japan coming in here at 11. Southeast Asia is well represented there, right, as well. You'll notice not a lot of European countries in the top 10, but part of that reason is because Europe's a relatively small land area, so there's a lot of countries there. So between all of those countries and people, it's still a very populous place. All right, you're going to be taking a look at some population information for a couple of focus countries as well. Here we go. Here's what we just looked at. Look at this population distribution map. Look at this awesome dot map. Every dot equals 500,000 people, right? And take a look at this. The red areas are the clusters. That's where you're seeing huge numbers of people. So East Asia, right? Look at China right there. Oh my gosh, right? You'll notice Eastern China, the eastern half has almost everybody, all right? Then look at South Korea there. My goodness, it's all red there as well. So they're fully populated. Japan, highly populated, right? Hong Kong, highly populated as well, all right? I should say Taiwan, highly populated as well. All of those in East Asia, my goodness. Then South Asia, look at India, holy moly, it's like a big red splotch. Look at Pakistan, right? Look at Bangladesh, all right? My goodness, look at that population growth. No wonder why it's the second most biggest cluster in the world. So right there, East Asia, right there, South Asia. That makes up, again, close to 40% of the entire world's population. Then Southeast Asia, down in this area, all right? So it includes everything from Indonesia, the largest, to Vietnam, right? Thailand is here. You got Laos, you got Burma, right? You even have the Philippines, usually considered part of Southeast Asia. And so combined, this area, again, makes up the 3rd largest cluster. And then, of course, look at Europe. Right? Look at that European cluster, how large that is. No wonder. Now, it's not as much land area, but still, we have a lot of folks that are clustered in the countries of Europe that you're going to be learning about this week and next for your Europe map quiz. Now, a couple of others we want to recognize. Look at West Africa, the fastest growing. Doesn't look as red now. Give it 20, 30 years, it's just going to blow up and be red, 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 red in all of these countries. And then look at us over here, right? Eastern North America. You get all of the East Coast, all the way over to the Great Lakes, and then you even have parts of Canada that are highly clustered right there. Now, are there other clusters in other places? Sure. Brazil, Mexico, west coast of the United States, right? But the point is, those are the 4 largest. East Asia, Southeast Asia, Europe, and then you need to know these other 2 for other reasons. All right? Now, how do we determine population in a country? How do we determine its change? Well, the answer to that is we use 3 different measures, all right? And the first of these measures is something called crude birth rate. Now, crude birth rate is the total number of births each year for every 1,000 people alive in a country. So the fictitious country of Majuskia, CBR. Let's say the CBR of Majuskia is 10. Well, that means there's 10 babies born for every 1,000 Majuskians that live in that country. Okay, that makes it easy, right? So we can see how many births are being produced. Some are going to have more, some are going to have less, depending on which country we're looking at. We're also going to measure something called crude death rate. All right, crude death rate means, and the abbreviation is CDR, it's a total number of deaths each year for every 1,000 people's alive. So it's very similar to CBR. So I might have a crude death rate of 8 in Majuskia, which means 8 people die for every 1,000 people that live in that country every year. And then, most importantly, based on birth and death rate, we can figure something called the NIR, or the RNI. It's different ways of abbreviating it. It stands for the rate of natural increase. And that's the percentage by which a population grows in a year. It's the natural rate of growth. So we're only counting births and deaths here. We're not talking about migration or anything like that. This is just a measure of your natural population growth. So crude birth rate, first off. In order to determine the rate at which a population is growing or shrinking, we need to know the number of people being born and that also die in a country each year. And that's where CBR comes in. All right? Now, again, like I mentioned, CBR is the total number of births each year for every 1,000 people alive. And we already kind of talked about if it's a 10, that means 10 babies born for every 1,000 Majuskians living in that country. CBRs are usually over 20 or around 20 in most LDCs, 20 or higher. And they're usually 15 or lower in most MDCs. Why? Well, in MDCs, people tend to have fewer children. All right? There's a lot of reasons for that. One, we have healthcare systems where contraception and other things like that are more readily available. All right? In addition to that, children are more expensive in developed countries. In an LDC, a lot of times kids are considered possible workers for the family. So if the family is farming to survive, the more kids they have, yes, it's more mouths to feed, but it's also more hands that can work those fields to grow more crops. In an MDC, right, people aren't really growing crops for those needs any longer, and so you don't really have as many kids because they're not really seen as much of a benefit. They're seen as more of a burden, especially with the high cost of children in many MDCs. All right, crude birth rates worldwide, check this out. This is good info. So where is it highest? It's highest in sub-Saharan Africa. All right. It is also high throughout most of the rest of Africa and into Central, Southwest, and South Asia. Alrighty. Where is it low? It's low in the most developed places in the world. North America, Europe, right? Japan, Oceania. Russia's birth rate is low. China's is low, but it's low because of a policy that they passed in the 1980s that we'll get into later. Crude death rates is the number of deaths each year for every 1,000 people alive. Again, if the CDR is 10, that means 10 people die every year for every 1,000 people that live in our country. Now, CDRs are usually over 15 in most LDCs, and they're oftentimes less than 10 in most MDCs. Why would that be the case? Well, LDCs, developing countries, usually have developing healthcare systems, right? Less medical access, less medical care, not as high quality medical care, and so we have more people that die at earlier ages, right? We have more people that cannot be saved, that are not able to survive illnesses or disease or injuries. Meanwhile, in an MDC, that's not as much the case. Now, not everybody makes it, of course, but it's oftentimes less than 10 in most MDCs because those healthcare systems are more advanced and, quite frankly, are able to keep people alive more often. All right? Crude death rates worldwide. Now, check this out. Again, our highest rates appear to be in sub-Saharan Africa, right? But we also see some crude death rates relatively high in South Asia, right? In Central Asia. Shoot, even in parts of Europe and Russia as well. So death rates don't completely correspond to development because some of the areas that have the highest death rates are considered more developed than other areas that do not have as high of a development. So birth rate is a measure of development. It doesn't look like death rate is as much, though. All right, so why do we figure birth rate and death rate? Because it tells us this. Again, the NIR or the RNI. It's the percentage by which a population grows in a year. It's the natural rate of growth, so only births and deaths, no migration is included here. And how do you figure out the NIR? Well, it's pretty simple. You subtract the CDR from the CBR. You subtract the crude death rate from your crude birth rate number. Now here's the thing. Those are out of 1,000, right? And we need a percent because percentages are easier to understand. So after we do this math, after we subtract the death rate from the birth rate, because those are for every 1,000 people in a country, we need to move the decimal point one to the left. And that's going to give us the percentage in that country of growth. So let's do an example here. You convert the CBR and CDR from number per thousand to percent. And again, how do you do that? You do that by moving the decimal point one to the left, right? Then the NIR is displayed, and it's displayed as a percentage, right? So if it's positive, that means the population is increasing by that percent every year. If it's negative, obviously that means the population is decreasing by that amount every year. So again, folks, if my crude birth rate was 20 and my crude death rate was 10, 20 minus 10 equals 10, right? That's out of 1,000 people, though, in my country. And I want to make it out of 100 so I can turn it into a percent. So I would take that 10, right, and I would move the decimal point one to the left. And suddenly it would become a 1.0 instead of a 10.0. And that tells me the percent at which my population is growing. My population is growing at 1% a year. The NIR is currently worldwide 1.2%, and that's why we have about 7 billion people, and we have about 70 to 80 million that are being added each year, because 1.2% of 7 billion is 80 million. The all-time NIR high is 2.2%. That was in the 60s, but it has declined since then, so we've gone from 2.2 to 1.2. So again, our population growth is still happening, but the rate at which we are growing is much more reduced than it used to be. And if these trends continue, eventually we'll get to a point where population is not increasing at all. It's flatlined, and maybe even will start to go down. This is the NIR worldwide, folks. So this is a rate where you take the birth and the death rates, and you subtract the death from birth, and you turn them into percentages. And this tells you where most of the percentage of growth is worldwide in this country. And as you can see, Sub-Saharan Africa, very well represented. This is why we think most of the growth that's going to happen in the future is going to take place in developing countries, and especially in Africa, because they're the countries whose rate of growth are at the highest. They're considered the least controlled anywhere in the world today. There are some other examples: Central America, parts of South America, right? Parts of South Asia. But all in all, it's Sub-Saharan Africa where you're seeing most of that growth. And it's over 2%, all right, per year. That's how much their population increases. So again, worldwide population NIR is 1.2%. All-time high is 2.2%. The NIR exceeds 2% in many LDCs in Africa and Asia. But it's actually negative in some places, especially Europe. That means those places that have a negative NIR, without new immigration into the country, there would be negative population growth there. So the only thing helping those countries to grow is immigration coming in. The United States is very similar. We're not yet negative growth, but we're close. And so immigration is pretty much the major reason why our population goes up every single year. Now, hey, those are going to tell us some data about a population, but they're not going to tell us everything. And so we want to look at some other population measures that we can use. Here's another good one that we can use to compare countries and regions around the world. It's called total fertility rate, and it's the average number of children that a woman is planning on having during her childbearing years. Now, the UN defines childbearing years as 15 to 49. You could have them earlier, you could conceivably have them later, but those are the prime years for women to have children in their adult lives. Now, TFRs vary widely, but LDCs usually have higher rates and MDCs have lower ones. LDCs have more kids per woman. MDCs have fewer kids per woman. And again, worldwide TFR is about 2.6. So the average woman worldwide is having 2.6 kids, all right, in her lifetime. The highest number is Sub-Saharan Africa, 6 children per woman in some of those countries. Also South Asia, very high. The lowest numbers are in Europe, where the average woman is having just 1.9 children per woman. So again, developing places, women have more kids. Less contraception, right? They start having kids at earlier ages. They have more throughout their lives. They may not work outside of the home as often, and so they will naturally have more children as a result. You look at the MDCs, right? Women tend to have fewer kids, right? Many of them are in careers or going to school longer, so they delay marriage, they delay childbirth, and therefore they have fewer throughout their lives. They spread them out more over time as well, because they want to balance having kids with careers and with education more of the time, right? They also have better access to birth control and other contraception. So therefore, they're able to prevent unplanned pregnancies more of the time thanks to that access, all right? Now, hey, do we have families in developed countries with tons of kids? Heck yeah, we do. We've got that Duggar family that's got like 50 of them. I don't even know what the show is. 25 and counting or something like that, all righty? Do we have families in sub-Saharan Africa with fewer than 6? Of course we do, right? But we're talking averages here. And so just by looking at the number of children per woman, you can draw conclusions about the development rate of that area. One other thing, remember, developed countries, women have fewer kids not only for the reasons we talked about, but because, well, kids aren't seen as valuable to everyday work. In LDCs, that kid oftentimes is working at home, right? Is doing chores, is helping to make or prepare the food. And so you need more of them, right? Also to account for the fact that more die during childbirth, so you need to have more to make up and replace. In MDCs, that's not the case, right? Our infant mortalities are very low. Children are going to school, right, and engage in all these other activities more often that are costly and expensive. And so what we see in MDCs is people have fewer kids. All right. Total fertility around the world. The darker areas have more. Look at sub-Saharan Africa, right? A lot of growth there. Look at IMR, infant mortality. Wow, it's almost a carbon copy, just different colors, right? And again, we have a lot more kids in this area to make up for the fact that the people know fewer kids are going to make it through childhood, right? And then let's take a look at life expectancy. That's the other measure we want to look at here. Life expectancy is highest in places where they have fewer children because they know those kids are going to live, on average, long, healthy lives. And life expectancy is lowest where we see the most kids being born, again, to account for the fact that people don't live as long. A lot of folks worry about kids not making it through childhood, and so they're going to have more kids to kind of offset that or prevent that or make up for it moving forward. All right? Now, how is world population growing like Pinocchio's nose? How has world population grown like Pinocchio's nose? Well, it just keeps growing and growing and growing. All right? World population grew from 3 to 4 billion people in about 14 years. It grew from 4 to 5 billion in 13 years. It grew from 5 to 6 in 12 years. Are you seeing the trend, right? If you look at those numbers, you can get alarmed. You can be like, oh my gosh, we're not that far away till we're going to be like doubling before you know it. Well, it doesn't look as bad as that trend indicates, all right? Now, a couple of other keys you need to know. Doubling time. That's the amount of time it takes for your current population to double in size based on its current rate of growth. So the world doubling time is currently about 54 years. So if our population continued to grow at the current rate it's at the rate it's at right now, in 54 years, in theory, we'd be on the verge of doubling. That seems ominous, but in the 1960s, that number was 35 years. So just since the 1960s, our rate of growth has slowed down enough where our doubling time is a lot higher than it once was. And look at a place like the U.S. The United States' doubling time is over 120 years because our rate of growth is so slow. So if current patterns continue, right, our doubling time for the world is going to get higher and higher and higher every year because the rate at which we are growing continues to go down, all right? But in an LDC with a high population growth, they're going to have a very quick doubling time, maybe 30 to 40 years. And every 30 to 40 years, in theory, their population will have doubled over that span, All right? So doubling time can be troubling if we don't have our population under control. Finally, the rule of 70. It's an easy way for you to figure out doubling time of a country. You take 70 and you divide the country's rate of increase. So, the example I gave earlier, Majuskia, remember the rate of increase, the NIR was 1%. So if you take 70 and divide it by 1, our doubling time in theory will be 70 years. All right? Now, 95% of all of the population growth worldwide is clustered in LDCs. 95%. So again, only 5% is happening in the developed places, in the wealthiest places, the places that are most able to provide for that growth. The remaining 95% is happening in developing places where those countries are already struggling to meet the needs of their current residents. All right. Finally, I'm going to ask all of us to identify some focus countries here and to list them on a spreadsheet. You're going to find your focus country information. And you're going to determine what its population rank is and what its overall population is, and then you're going to record some other calculations as well. Look to the next part of this assignment to determine what those will be.